Hello everyone. In our fluid mechanics lecture series, today we are going to study about the dimensional analysis. Okay, so there are the two types of or the two methods of dimensional analysis. Out of that, first one is Rayleigh method. So by using Rayleigh method, we will find out how to calculate or the how to analyze the dimensional analysis. Okay. So for that, to understand the Rayleigh method, we have considered here the drag force relation, and we know that the drag force is the function of length, density, kinematic viscosity, velocity of fluid, and acceleration due to gravity. Okay, so based on that, we have written down here the expression as the drag force is capital D is the function of the L as a length, then rho as a density, mu is kinematic viscosity, v is velocity. So v is mu is kinematic viscosity, v is velocity, and g is acceleration due to gravity. Okay, so now we will find out dimensions of each terms here. So here the first one we have the drag force. We know that force is equal to mass into acceleration. So by using that equation, we will find out here the ml divided by theta square. So m is for mass, L for length, and theta is for the time. So we know that mass is measured as so mass is denoted as m, and acceleration, we know that formula of acceleration is length upon time square. So length is L and time square theta square. Okay, so now here L length as again L, density, we know that density is equal to mass upon volume. So we know that mass is denoted by m and volume is length cube. So it is ml raised to minus 3. Kinematic viscosity is mass upon distance into time. Okay, so based on that, here we have find out the dimension as m L raised to minus 1, theta raised to minus 1. Then you know that velocity is distance upon time. So distance is L, that means length, divided by time is theta. So is equal to L theta raised to minus 1. Then next is acceleration due to gravity. So we have already found out here acceleration due to gravity, or the acceleration L divided by theta square. So L divided by theta square. So this is equal to L theta raised to minus 2. Now equation 1 becomes, so this equation becomes, we will write down here. So D is equal to capital A L raised to A. So we will substitute all the dimensions here and taking the A is, we have considered here arbitrary constant, any constant we have considered, and for each term we have given a specific index. So for L we have the specific index as A. So L raised to A, density rho raised to B, kinematic viscosity mu raised to C, then velocity D raised to D, and acceleration due to gravity g raised to a. So this is our equation 1. Okay, now next one, here we substitute all the dimensions here. Okay. So from here we will substitute the dimension. So drag force have dimension ml theta raised to minus 2 is equal to a as it is, L raised to a, because L is as it is a L, and here for the density we have L raised to minus 3. So m L raised to minus 3 bracket raised to b. So we have considered b as the index of the density. Then kinematic viscosity mu m L raised to minus 1 theta raised to minus 1, m L raised to minus 1 theta raised to minus 1 raised to e, because raised to c. So we have considered here mu raised to c. So that's why we have here this c. Then velocity. So velocity is L theta raised to minus 1. So L theta raised to minus 1, and here in this equation we have considered v raised to d. So bracket raised to d here. Then acceleration due to gravity g, L theta raised to minus 2. So L theta raised to minus 2, and if you consider in this equation we have considered g raised to e. So here bracket raised to e. Now we will take separately the m terms. On the right hand side we have considered m terms at one side, L terms at one side, and c terms at e at once. Okay, so that means we are combining m terms, L terms, and theta terms. Okay, so now if you see here how to consider, we have m terms. If you see here m raised to b here, so m raised to b, then m raised to c, so that means m raised to b plus c, so here m raised to b plus c. Now here L, so L raised to a, L raised to minus 3 into b, so L raised to a minus 3b, then here L raised to minus 1 multiply with the c, so L raised to minus c, L raised to d, so here d, plus L raised to e, so L raised to a minus 3b minus c plus d plus e. So likewise theta, so theta term is theta raised to minus c, theta raised to minus d, and theta raised to minus 2e. So based on that, theta raised to minus c minus d minus 2e. Okay, now so now equating all the m, l and theta terms on both sides. So for m we have, if you see from the equation, 1 is equal to b plus c, then L is equal to, from right hand side we have L raised to 1, so 1 is equal to a minus 3b minus c plus d plus e. Okay, then for theta, for left hand side we have theta raised to minus 2, so that's why minus 2 is equal to minus c minus d minus 2e. Okay, so we have considered this is the equation number 3, this is 4 and this is 5. After solving this equation, so from equation number 3 we will solve b is equal to 1 minus c. Okay, so b is equal to 1 minus c, and after solving this equation number 5 we have d is equal to 2 minus c minus 2e, and here for a, from equation number 4, a is equal to 1 plus 3b plus c minus d minus c. Okay, now here from these two equation again we substitute in this equation. So solving above equation again, we have a is equal to 2 minus c plus e. Okay, now substituting the values of a, b and d, so a, b and d, and in the equation number 2, so we have d is equal to capital A, because it is a constant, L raised to 2 minus c plus e. Okay, so this is the value of a. Then rho is equal to L minus, rho raised to L minus c, mu raised to c, v raised to 2 minus c minus 2e, and g raised to e as it is. Okay, now we'll take L as L square, L raised to L minus c, L raised to e, then rho raised to 1, rho raised to minus c, mu raised to c as it is, v square, v raised to minus c, v raised to minus 2e, and g raised to e. So after solving this, d is equal to a L square, then this rho and this v square. Okay, now taking the c terms at one side. Okay, so c terms together, so we have m raised to c, so m raised to positive c, so that's why m mu raised to here c, then L raised to minus c, so that's why L is at the denominator and this is c, and rho raised to minus c, again rho is at denominator raised to c, and v, so v raised to again minus c, so that's why v raised to c. So this is about the bracket c, so mu divided by L rho v bracket raised to c. Now similarly we will take it e terms here, so L raised to e is positive, so that's why L e raised to e, then here g raised to e is positive, again g raised to e as it is, and if you see we have v raised to minus 2e, so that's why v square is at bottom bracket raised to e. Okay, so this is about our equation. D is equal to a L square rho v square in bracket mu divided by L rho v bracket square bracket raised to c multiply with in bracket L g divided by v square raised to e. So this is about the drag force relation with the function of length, density, kinematic viscosity, velocity and acceleration due to gravity. So by using this one, we will find out this is the formula for the drag force. Okay, thank you.